third speaker in this session is Thierry ERNST. Now he got his PhD from Université de Grenoble a few years back, and then has spent about a decade now as a researcher at INEA, coordinator of a big European project, has been involved in standardization activities now in a number of cases. He's currently the president of the Association for IP version 6 Promotion and Training in France. And most relevantly here, I think he is the CEO and co-founder of YoGoKo, which is a startup company specialized in intelligent transportation systems. Please.
Okay, thank you. So I hope you can hear me well, or both for here, I know it's for sure, and remotely. So I'm going to do this presentation a bit less, we'll say, scientific than the other talk that you had. Speaking about standard technology, so for some of the people that might be very obvious things, but I think it's also important to have an idea about where the standardization is going, where it is already today, and what are the issues that it needs to be dealt with, because at some point in time, the research we do also have to be put on the market at some point in time, necessarily, and we need to take care about both technical issues, but also IPR issues sometimes, and political issues that are related to standardization. In standard, you don't always take the best solution. Sometimes you take the solution that has been voiced the most by key players, or that has been proved easier to implement. Maybe with less performance. Sometimes with no, we hope that standard gets have a roadmap for long-lasting deployment, but it's not always the case. Sometimes you start with technologies that gets you into the trap of. I mean, I don't know how to say that in English actually, but a road with no a dead end basically, and that happens a lot. So I'm going to speak about cooperative ITS standard. It includes V2X and other technologies, but I hope that after my talk, you are able to make a distinction between different technologies and keywords. So the terminology actually is very important. So I have quite a lot of statements about terminologies in order to help saving and making the distinction between things. So I hope it works well. Yeah, I'm not in. Apparently, I forgot to put in myself into the proper mode. Sorry for that. I need to put that in presentation mode. You can still get it on the screen, everyone.
Yes.
Yes. Fine.
Please remove this window.
Okay, you have it also. Sorry
Great.
for that.
Yes.
Okay, sorry. Now it's a face-to-face meeting. We need to again learn how to do things. Yeah. So basically, the first to start with, we are in this topic. We are going to speak about autonomous, and I mean the vehicle will be autonomous in the end at some point in time, long time from now. Probably if we speak about fully automation. But what is important is before the vehicle gets automated in some circumstances, it has to be connected. And it is already connected, and it will be cooperative. And cooperative is a new notion that the vehicle has to cooperate with its surrounding environment. That means with the other vehicles for road safety and other needs. Platooning is an example. It's not road safety, but road safety is involved in platooning. But platooning is good for efficiency of transport of people and goods. So safety is important, but cooperation between the vehicle will be important in platooning case in order to synchronize the operation of the platoon. And also to merge and split platoons, etc. That's one of the use case, but it's not the first that will come. One use case that is going to come very quickly, as soon as autonomous shuttle like Navia, for instance, gets deployed on the road, is coordination of the vehicle with the roadside at the traffic lights. Because traffic lights with communication with the vehicles is one typical use case where communication can help secure the crossroads. So not as a single solution, but as an additional solution in order to provide, I would say, resilience and basically combination of technologies with sensors, video, camera, and communications together makes and we'll get we get us into a situation where we can say that we can safely operate autonomous vehicle at crossroads. And so those are examples that highlight that yes, the vehicle will be autonomous, but it will be connected and cooperative. So that means it will share data for many different reasons with its surrounding environment. I said about communication with other vehicles, but it's also communication with roadside infrastructure. So traffic light is one example, but it could be with lights. I mean lighting in the road, because if you could detect an approaching vehicles, you can you can increase the highlightment of the street, or if you detect a pedestrian of the road, you can highlight the road so that the autonomous vehicle detect the pedestrian better. And all of that is also, as for the traffic lights, it's a combination of sensors with communication that will make it safe and efficient. But I also need to mention vulnerable road user. That's the term that we use in the standardization to speak about pedestrian and cyclists, because in most situations, those people are so far have been ignored in the topics. And when we speak about road safety has improved a lot with with new technology like augmented driving system, ADAS systems and other technologies. But pedestrians and cyclists are still people, those people where we don't see a decrease or not sharp decrease, at least, of casualties. And that's one of the priorities of the European Commission and other stakeholders. So we speak about vulnerable road user when we speak about pedestrians, cyclists, motorcyclists also, because those are in the same situation. So those people also need to exchange data with the vehicle. Actually, we will be in a situation where we will have vehicles or other entities that do have the ability to communicate together with others who don't have ability to communicate. So it's not possible in a near future to get all the, I would say, the mobile entities on the road be able to communicate. So it's something we need to take also care. Okay, so that's what I wanted to say as an introduction. And it seems that I can, it's unblocked or what? No, it doesn't take, it doesn't react.
If you click on the center of the slide, and then.
Thank you.
Yeah.
Okay, so basically, as I said, the vehicle will be connected and cooperative. And here, what I want to emphasize is the data the vehicle has to exchange is both with the surrounding environment. I gave you an example of use case, and also, of course, with distant nodes. For instance, if we speak about remote driving might be useful for in a situation where there is a sensor that is damaged and you need to safely put a car that has automated capabilities into on the road, or maybe in a platoon where you would have one human driven vehicles like other vehicles. You could have also the situation where you do valet parking, so situation where you have a car, you leave your car and the car is getting to park by alone. That could be done either using its a single operation mode, I would say, but sometimes it could be done with assisted remote driving. So remote driving is also one use case. If we just speak about autonomous vehicles, but my talk about CEITS is not considering a necessary autonomous vehicle. It considers all situations where connectivity and communication can improve safety. And speaking about deployment, of course, it's not with automated related use case that we have the more, I would say, short-term possibilities. For usual cars, I mean, the first traffic light that is equipped with, for instance, V2X communications, it can provide a service to the first vehicle that is equipped with interoperable system. Like you get the traffic light duration, so you know when the light is going to switch. That's useful because you can save fuels, for instance. It's also useful to at traffic lights to give indication about approaching vehicle in the other section of the road for safety, or maybe to detect pedestrian on the road. And there is a message that I'm going to speak more about that. It's called CPM. It's a cooperative perception message that is getting to assist safety at traffic roads by detecting pedestrians, for instance, on the road and getting this information to the vehicle. And in the both direction, a vehicle could detect a pedestrian and give this information to this surrounding environment. So that could be put in place for as soon as the system is validated by OEMs or by aftermarket solution provider, it could be deployed on the road. So we don't need to wait for automated vehicle to get such solution. And my talk is also going to be very much focused on that kind of use case. So basically what we have to remind is that we need communication and sharing of data. And we need to do that both locally and remotely, and that has implication about the technology to be used and the technology to be standardized, etc. So the situation today is that the vehicles on the market already come with a lot of communication capabilities. So it could be either today's vehicles or the future vehicles. It could be especially bus or trucks. I mean, utilities vehicles are equipped with much more communication capabilities, or ambulance, police cars, etc., because they have a market value that is much more important than individual car. So here, my drawing is using an individual car, but it's more, I would say, relevant to speak about utility vehicles. So the vehicle comes with, of course, cellular connectivity for many applications, including navigation. It comes with GPS. You can say that in some situations that it's a kind of communication capability. It's you receive something from the outside, so it's a communication capabilities, but you don't send back. Of course, V2X communications. I will talk more about V2X later. You could have all the technologies, Bluetooth, or infrared communication, etc. So basically, the drawing is that vehicles come with many communication capabilities. But all of them are usually integrated in the vehicle for one specific service or just a set of services, but not to fulfill the entire set of services. So the situation is that we get into a silo type of a scenario where you have a system that has been developed for a very specific need. The reason is both because there is a need. So there is then an engineer that designs a system that corresponds to that need. It might be standardized if it's important to be standardized, or it might be totally proprietary. And you don't get the full picture because the deployment cycle of the vehicles is between 3 and 5 years. And we don't look necessarily in a solution that for the vehicle in 20 years from now. So you get, there is more and more technology integrated in the vehicle with more and more communication capabilities, but no communication capabilities can replace another one in case one communication capability is destroyed. For instance, eCall is a standardized solution that has been that is obligatory now in new series of vehicles since 2018. I think it's after 10 years of 20 years of research and 10 years of lobbying at the European Commission. So now every new brand, new series of vehicles needs to get this eCall. The eCall is a service that in case of accident or any other emergency situation, you can automatically be connected to some backhaul that is going to assist you by voice, and but if you have an accident and you are not able to speak at all, the system can automatically detect that you are in a situation, like even some parameters like the engine is still running or electricity is running, that kind of thing. There are a few parameters that can be set. This is done over 2G networks, 2.5 actually. It's not 4G, it's not 5G, and some people know that the operator, telecom operator, wants to stop the 2G technology. So this is a big issue because a solution has been standardized and is mandated in all vehicles with a technology that has a limitation of life. So at some point in time, people will say either we need to keep the cellular network in the second generation of the cellular network up, just because there's such kind of use case, and it's not only in the automotive market, it's also other situation, or someone has to pay the price to replace the system with a compatible solution, and that's an issue because cars have, in average, 13 years of duration of life in France. Many of them have 17 years or even more. So we have a big issue here. So my talk is also to emphasize that when you speak about STENA, and this is my role in standardization actually, is to be sure that what we develop is long lasting and is sustainable, so that it can integrate in new technologies. Because the life cycle of new technologies, every 18 months, there's a new radio technology that appears on the market or that is discussed or with more or less lobbying. But new cars, new cars are developed every 5 years and have a 20 years duration. It is much more than any cellular technology or wireless technology that we know. Maybe Wi-Fi is not the most longest used technologies. So equal is just an example, but the same happens to other technologies. So you have a specific use case that has characteristic or requirements. So then you end up to develop a system, so with hardware and software, that is going to fulfill exactly these needs with the lowest cost possible for the producer, for the equal solution in the vehicle. Unless we were speaking about utilities vehicle, but for the I would say individual vehicles, it has to be extremely cheap. So it's by extremely cheap, it means less than 10 euros for the hardware system. For V2X, the people speak about 100 euro maximum, and 100 euro is already a lot, a big price to pay. So basically, because of those type of requirements, there's a tendency to develop system with the lowest level of functionality possible, which prevent integration, innovation, and I would say to get out of this silo type of deployment. But we try to do things better by at the standardization level by defining ways to ensure that interoperability between systems. So we get into this situation where and that's the justification of some of the work that I call CITS, and this is where we make a big difference between CITS and V2X. Some of the people maybe who already learned about those technologies sometimes speak about CITS or V2X. Interoperability, without making the difference, but it's totally different. V2X, it's localized communication around you, with us, and it's broadcast usually. Because when you have spoken this morning about platooning and V2V, but in what is already in the standard today, it's only V2V, it's only broadcast. I mean, so it's only part of the story. So, so the big pictures is we want this to be able to have this exchange of data between all the vehicles, all the type of road user, so that vehicles and non-vehicles, the roadside infrastructure, but also the urban infrastructure, because we are aiming at fulfilling the needs of mobility of goods and people. And the urban environment is very important because you get parking involved, you get logistics, supply, etc. That is also involved. It's not only about safety, road safety and road efficiency. It's also about improving all the transmission of data and people and goods on the road. And that's important. That's what we want to achieve. We don't want to have here on the picture there are 5 different systems, but we don't want to have a different system for each use case or each set of use case, because you understand that it's not sustainable. Like you don't build a new road every time there's new need for traffic, because in the roads you end up with having 10 lanes of roads, and because the more you provide, the more you get on the road. It's the same for communications. Actually, it's the same with 5G. Is going to be an enabler of new services, but it's also going to, because the promised bandwidth that goes with 5G is a bad signal for the people to say, oh, because I have a lot of big tubes to transmit the data, then I can transmit any data, but you get in the trap of having too many non-improved system. We have the situation where we will not be able to get back on. I would say in a safe mode situation, in case of war, in case of tsunami or whatever, in a situation where you can ensure resilience of the system. So we need to be careful with that. And that's one of the ideas behind Cooperative ITS. Cooperative ITS has been put on the table at the European Commission 20 years ago. The first projects that are European projects that have been funded by European Commission are started in 2006. it was not called CITS at that time. It was called cooperative systems. But the fact that it started in 2006 means that the European Commission had that included in the roadmap many years ago. So it's really 20 years ago. And in the standardization, we started with different keywords. It was not called CITS either, but we started to normalize functions for interoperability and sustainable deployment in year 2020. 2000. So it's 20 years old. So that's what we want to achieve. How can we ensure there's a transmission of data in all those situations between all those stakeholders? And here I don't speak about what is the technology behind, because the technology is going to be an answer to the question of how we do that. The first thing we need is we need to agree on an harmonized communication architecture. And of course, the requirements that the next level of requirements is that we identify what are the possibilities, and we consider that we need to have localized communications with no infrastructure support. We need to have long haul communication with infrastructure support. We want to support safety-related services, and safety-related services could be time critical, or it could be non-time critical, but with still this safety of life requirements. And that has a very important in terms of latency. If we speak about a time critical safety, road safety application, latency is very important. If we speak about non-time critical safety application, latency is not important, but the fact that the data is transmitted and obtained is important. So that's totally different requirements in terms of communication protocols, networking, etc. The other, so we want to support safety application, both time critical and non-time critical, traffic efficiency, and all the other categories of application. We call it value added services, because they have this less impact in terms of implication to the life of the people, and in the term of implication of the use of the road networks, which is a limited resources. And it's also because at that time the people didn't have much ideas about what would be the idealistic application to put on the table so that it attracts the attention of the people. We could speak about parking services, platooning, of course, or in valet parking, delivery of goods. We could speak about access control in the city, in the urban city, like only a vehicle with more than 2 people, or only the people that have a need, or whatever scenarios in mind. And also, of course, we understand that the solution has to be not only we want to avoid silo solutions. So we don't want to have a multitude of solutions, but one harmonized set of way to transmit the data. But we want to ensure that it works everywhere, not only in Brussels or in Paris or Strasbourg or whatever. It has to be at least at the level of a region like Europe. It has to be the same. But if you listen to the car makers, it's even more complex, because some car makers are, of course, they want to sell the same type of vehicles in several continents. And Europe, actually, it's difficult to say where Europe stops. That actually vehicles sold in Israel, for instance, are typically the same as the one in Europe, and Russia also, etc. Those big countries. And you have the second-hand vehicles that get to Africa many times. So it's very tough to decide. And when we speak here, it's very important to speak about interoperability much more than the vehicle produced 20 years ago. So when you get vehicles with communication capabilities that are sent as in the secondary life in Africa or wherever, what happens if in Africa they have decided for different, I would say, system architecture for communication, like emergency call or whatever? It doesn't work. So what's the value of those vehicles? In the future, all the vehicles will be maybe electric, all vehicles will have ADAS. If that we cannot ensure interoperability, it's a big mess for everyone. So it's also important to consider that. So we have decided, I say we because I also participate to this work from the day one at ISO. I got involved in the ISO standardization in year 2001. So just at the second meeting they had. And I work there as my former position as a researcher at Keio University in Japan, and then at INRE and Mainz Paris. But basically, the idea is to have an architecture that allows the share of data between all those entities that we have identified, that is able to support all those type of services that I mentioned, but also that could combine multiple technologies, because there is not one technology that could fulfill all those requirements. This is obvious. And we have identified both short range, medium range, and long range communications. And at that time, when this started, we speak about millimeter wave, about satellite, about cellular, about Wi-Fi, DSRC, about infrared communication that was also on the plates, and could be other. And in the recent years, we have spoken about Bluetooth, LoRa, that's usual technology that are used for many devices that are cheap. So it also has to be integrated, because, as I said, we need to include the vulnerable road user, and also we need to include the people who are waiting for a bus or waiting for a car or taxi, whatever. They need to be able to exchange data with the car. And when we speak about autonomous vehicle, maybe you need to identify yourself to the car in order to get into the car, or maybe for autonomous delivery vehicles, you need to open a door. So you need to have short-range communication or long-range communication, doesn't matter. But you need communication also between those people that are equipped with a cell phone or whatever, together with the car. So the architecture has to include the possibility, I mean, must be able to include any type of technology that is widely used for services, even though it has nothing to do with safety. It has to be integrated. So the architecture has been designed in a way that you could integrate a new communication technology. This is why you have a layer architecture. I think most of the people here are familiar with the typical ISO or OSI model for 7 models. So if you are not, please raise your hand. I think most of you are, so I don't need to get into those details. So the architecture here is not a 7-layer architecture, like TCP/IP is not a 7-layer architecture. It's a simplified architecture where we say, okay, we have applications. At the top, at the bottom, we have the communication technologies with the physics of the technology. In the middle, you have a networking layer. So here it's combined network and transport, because at the level of thinking for ITS, there's no need to make a clear separation between those two. On the paper, I mean, even though on the implementation, you still need to respect that if you have TCP/IP communication, then you still have a network layer and transport layer. But okay, that's communication part. And actually, this distinction is sufficient for the people who are working on services, because they don't need I mean, the people working on applications, they don't need to know the details, the physics of the communication, nor the details of the networking. They just need to know it's there. And the facility layer, that's a new stuff. It's all the functionalities that are commonly used by applications. I'll give you one example, and I will talk about that later in my slides, or maybe at the right time. But for instance, positioning. It's most of the application, when you speak about mobility or in vehicles, whatever, are some more or less they need position. So the position, you don't want each application to calculate its position. You want to provide it as a facility for all or most of the. It will simplify the development of the application. It will ensure that you have a better positioning system, because you can combine also different sorts of positioning and give the appropriate, I would say, position to the application with an indication of the quality. That is also important. Another one is what we call Adm Local Dynamic Map. It's a map, a database of all the data that you get into the vehicle through sensors, through V2A communication, through other means. So it's a database of containing data that is geolocalized and timestamped. This is very important, that you know exactly where the data have been produced, where it is relevant, so where and when. And that's also a facility for all the applications. All the applications that needs to do emergency braking or whatever, they need to get some type of information, and you want the application to be able to say, I want all information about surrounding vehicles. This information will get first registered into this database, so that you can get it to the application with a subscription mechanism that is also included there. Those are example, but you have other example of facilities. So the idea is to share things, to share the data. It's important to share the functions. And the novelties of that is to also understand that security is important. So it's emphasized with having a block of security. And security is a cross-layer issue. You don't deal with security just at the radio level, because if you do that, you don't provide anonymization of data, etc. It's not a good work. And the opposite is true. If you just secure the application layer, anyone can get into the middle. So we need to have this thinking about security, this cross-layer thinking. And the management stuff is there to emphasize that we need to manage the functions locally and remotely, but also we need to manage communication and security. Security has to be managed also. And communication is very important because if you want to support multiple technologies, you need a way to understand what are the communication needs of each application and to identify what is the best communication profile or communication stack, so which protocol and which radio technology is to be used at one given time, given the environment, I would say the radio environment of the vehicle. If you have no connectivity, no cellular connectivity, the application there might be a means to get the data that the application wants through maybe a network of vehicles, for a roadside equipment that is there. And this is what I was saying before. Emergency call today doesn't work if it's broken, it doesn't work. So if you are in a situation where you have a car that has that has fallen in a canyon, you don't have it's a place where you don't have cellular because in the canyon, you're deep in the canyon, you don't have, but you're still 100 meters away from the road. You are almost dead, but you're still alive. You have V2X communication that still works, but the e-call doesn't work. Nobody saw that you fall in a canyon. So your life is suspended to someone that is noticed that you're there. Emergency call doesn't work, it doesn't help you. You cannot push the red button to call anyone. But V2X works fine, the Wi-Fi works fine. So it means that any vehicle that's passed by could get you CAM message. It's a message that sends you the position. It will still be the same. But since emergency call is not connected with that, it will not get anywhere. All the vehicle will get you notice that there is your vehicle has sent a message and nobody will understand that you're in a dangerous situation. We want to solve that kind of problem because you have the communication capabilities. It's a shame that we are not able to save a life because just the engineer have not integrated things. And today they don't integrate things for two reasons. Well, three reasons. One is the cost. So they need to be in a situation where they need to provide. So for instance, if there is a regulation that by the European Commission that says that you need to provide emergency call by any means, they will do it. Otherwise, they will not do it. So that's one of the issues. They will not do it by themselves. The second is what they claim security. I mean, there is the OEM usually, but security because it's complex situation if you want to integrate solutions together. So we need to do a real thinking on security. And there is a lot of projects about security that we talk about at the end of my presentation. So that's one issue that can be solved. And I said free. Why I said free? I forgot. Okay. Anyway, there's good reason for that it doesn't work today, but we want to solve this problem. Okay, I spent too much time on that, but yeah. So basically, this drawing is to show that with this architecture that is standardized. I didn't mention that. There is two documents. It's standardized at ISO and ETSI. The version that all the standards at ETSI are publicly available. When it's published, it's for free, available for everyone. The problem with ISO standard is you need to pay to get them. So few people have access to those documents. The problem is in 2010, when the standard was published, it was published both at ISO and ETSI with the same content, but with a different format because there are different editing, requirements. But it was the same content. In ETSI, the document did not involve, so it's still the 2010 version. At ISO, it has involved in 3 steps. So by improving the terminology, improving the description, drawing, and also including new functions for security and communication management, for instance. So you have both two documents, and the risk is that if you have interest into that, you read only the ETSI version and have a limited version vision of what is there. So it's I really insist that there's two documents. It's the same starting point, but it's not the same content anymore. So this architecture can fulfill all the needs of communication for all use cases. But currently, the focus is definitely mostly on the road safety and traffic efficiency. There is a few efforts towards using CITS this architecture for other use cases, but it's not visible for many reasons, because of this. First, there could be so many use cases that the possibility to see that on Google or whatever is limited if you don't use the right keywords, but it exists. And there's more and more initiative using this architecture for urban type of applications. Okay, so another point. So my first point was that the design principle is to have a unified communication system. So that's what I was saying. But of course, I also mentioned about multiple communication. So that's the second design principle, is starting with the point that safety is important, and for safety services, we want to have the same level of quality of service wherever the vehicle could be. The fact that you are in an urban environment or in a rural environment. Really? Only 5?
Yeah.
Okay, so the fact that you have limited so it's important that we provide the same quality of service. So for that, there is no single communication capability that will give you the proper I would say solution. So we need to combine a communication solution for that first reason. The other one is because different applications have different communication needs. I mentioned about localized communication, etc. We also have no single solution that could fulfill these needs. So we need to combine multiple communication in order to be sure that we can do so. And here I mentioned about those communication capabilities, but I will not go into those details. So what we have to make to clarify is a distinction between localized communication and network communications, to be sure that everyone gets this well understood. So localized communication is really communication in the surrounding environment, but without any support from a telecommunication network or telecommunication infrastructure, because one of the requirements or understanding of localized communication is it has to work anywhere. So if you have a localized communication that rely on the fact that there is the MEC, if you speak about the 5G technology, that there is a base station, then it's not localized communication. It's a communication that requires the support of the telecom. So that's not in this situation. This situation is really no infrastructure. So this is why I put the cloud in this middle. Of course, you have with localized communication, you cannot reach further than some I would say distance, depending on the quality of the technology that you use, unless you use other vehicles that could be used as a relay. In this case, it could extend this coverage, but you are still limited in the coverage, of course. So network communication is the word we use to describe the communication that rely on a communication network. So it could be between the vehicle and the air traffic control center or whatever. It could be between the traffic lights and the traffic control center. Most traffic lights are connected to some remote control center using optic fiber, or sometimes with cellular, or even the LoRa communication could be used for sometimes in some situations, but stay still in the rural area traffic lights that are totally disconnected from everything. So it's not in this situation, of course, but just to mention. So network communication is also happening when you have communication between a vehicle and a roadside equipment that goes through either the edge or the core of some telecommunication network. So we have to make a clear distinction, because we understand that it's totally different in terms of resilience and in terms of a wide, I would say, availability, because A network communication can only work if there is a nearby deployment. So it might be case in a city, but in the countryside, it's most likely that it's not there. Even with 5G, we know that the distance, the quality of the bandwidth, etc., will not be the same in small cells and big cells. So it's also important to keep that in mind. So we have this localized communication, and when we speak about V2X, and this is something I need to make clear, because V2X, if you Google V2X, we see many times definition that it means vehicle to everything. This is the definition from Qualcomm. It's not the right definition. Because if you say that it's vehicle to everything, it includes both localized communication and network communications. And we need to make a distinction between the two because there is different implication and requirements. And when we speak about specification, it's important that we have the right terminology. So in the standard, it's defined as localized in one side and network on the other side. And V2X is localized communications between a vehicle and its surrounding environment. Localized. So it means not using the cellular network. And some people may have heard about cellular V2X. Cellular V2X is a melting pot because it's various technologies together. And it includes, for some people, it means localized communication. For other people, it means network communication. So it's unclear. And this is why it's a big mess on the market, because people have a totally different understanding of what is behind CV2X. So I will never speak about CV2X unless precisely mean which part of CV2X I mean, and is it localized or network? So this is very important for so in order to make sure that people understand each other. So I will not go into the detail, but for localized communication, there is a set of messages that have been developed by mostly at ETSI. So we call CAM. CAM is a message that gives the position of the vehicle at a very high frequency so the other vehicles can, with this information, understand that there is a risk of collision. This is the first need, but it could be used for many other use cases. We have the position, the trajectory of the vehicle, the speed, acceleration, and the braking angle. You have DNM. DNM is a message that is that after detecting an obstacle of our vehicle stop on the road, etc., that we provide this information using localized communication to other vehicles or roadside equipment, like a traffic light or roadside unit or whatever. We also have SPAT and MAP. That's the message that are sent by the roadside, the traffic lights for traffic for intersection at the intersection. Yeah. Recently, you have CPM. I mentioned that for the cooperation between the vehicle at the intersection to provide additional information about obstacle or pedestrian on the road. And there is recently more messages that are also in the standardization part. I will not mention that, but there's several other ones that are defined mostly at ETSI, and all of them are broadcast message. So it's not point to point. It's really a message that are sent. And for safety reasons, this is why it's broadcast. You want everyone to hear this message. So it has an implication on security that I will mention. So localized communication is not sufficient, of course, to provide a safety services. And basically, you need to combine both localized and network communication. Here, I'll give you an example. You have black ice. Black ice is something that is time critical for the vehicle that follow you. If you detect black ice, or if you happen to brake on the and slip on the black ice, it's an information that you need to send to the car that are just behind. So it's time critical safety information that needs to be broadcast very efficiently, very rapidly using localized communication. But the black ice will not disappear. So in the vehicle that will come in 1 hour are going to be affected by the same issue. So it's also safety issue for them, but it's not time critical. So in this situation, either you do nothing or you rely on a networked communication technology that could provide this information to the vehicle. So this is very important that if we send a CAM and DNM around us, that there is either a vehicle or roadside equipment or whatever that is able to catch this message and transmit it to some traffic control center that will later be able to transmit it to the other vehicles, either at the location where they need, or in a place where there is some roadside equipment, for instance, at a roundabout, or an intersection where you have decided that it's a good place to put a specifically roadside equipment that we call RSU, roadside ITS station. So it may be a network communication, it's a networked device, but it's designed to be there or for specifically for those type of applications. But you will not put roadside station everywhere for obvious cost reasons. So we need also to have the same information to the vehicles that are not in nearby any roadside equipment. So using network communication, so using cellular network is one good way to do so. So the standard at ETSI are started with broadcast communication only. And I don't have a slide for that, but they use what they call geo-networking. It's a protocol for distributing this information locally. It's not IP communication. Geo-networking is a protocol that is that inherits from the research on planet on vehicular ad hoc networks. The problem is that for this example I give you, you also need to transmit it to the cloud, so to the traffic control center with cellular. So you are going to use IP. The problem is because the standard has been designed to work on geo-networking with the security dealt at the geo-networking level. In order to transmit the CAM and DEM information to the cloud, we do it using IP with geo-networking encapsulated. This is totally inefficient and not a bad design. It's a bad design because the starting point of all of that was we only need the broadcast communication, which is totally not correct to my thinking, but it's the way we are today. So basically, we need to combine those technology, and here this is a way to. Okay, I will go quickly because I need 5 minutes. And
no, that's a bit much.
Really?
Yeah.
So I have most of the topic I wanted to give you. Anyway, okay. If you don't want, we can. How we do? Okay. So this is all I will say on that. So we have also the need for managing communication. So we have protocol and standard that explain how to generate all of that. I mean, how to get the requirements from the application and how to manage the selection of a communication stack and listening to the radio technology in order to make such decision. This is still work in progress for the decision-making mechanics, but it is a standard with all the functionality that have been identified. So the only question is how to fill the functions with decision-making stuff. So of course, all those solutions works for vehicle, roadside, smartphone also needs to be, I mean, personal device needs to be integrated, not with the same level of complexity, but they need to be integrated. Also together with ITS station in the cloud. I will not detail those, but you have different ways to implement. The standards are very open in a way that they don't tell you you need to put everything in a box. You could split that in several communication boxes, but you need to respect some rules. That's important. And it works the same for a vehicle, for a roadside equipment. It could even work for a train because there is a lot of situations first where the train has to interact with the vehicle, like at such kind of situation. And SNCF and Deutsche Bahn are involved in some of the testing related to that. So this is a very interesting topic for them. Security is very important. Unfortunately, I don't have much time, but just to say that broadcast communication don't need to be encrypted, of course. We want them to be heard by everyone. So, but we still need to maintain, I would say, location price of the driver and the people in the vehicle. So the system that has been developed is a system based on pseudonyms. So pseudonyms using certificates that are developed by IEEE. So I have all the information on the slide. So that you can authenticate the sender of the message. This is very important to be able to do so. So security is there. And the same certificate system has been used to secure point-to-point communication. So network communication, it's totally different here. You need to put to encrypt information. But instead of using different technologies, because for encryption and network communication, we usually use X509 certificate. But here there's a standard that is explaining how to use the same certificate system, the same security management system, together with IEEE certificate. So I also have the information there. So it's a combination of TLS together with TLS 1.3 with some specific extension that has been standardized at the IETF together with ISO. So that's there. And with that, you can secure the link between the vehicle and the roadside equipment with the cloud. And you can, with a gateway or firewall, you can limit the access to the information in the sense of the vehicle. So here, the sensors are not connected to NIT directly. They have to go through the gateway at the level 7. So that means you have no direct communication from the cloud to a sensor. It's always managed through some gateway. So that's important to mention. And just to go quickly on that, for facilities, I will not have time to discuss that. But there is some deployment of all of that with C-Roads. C-Roads is the pan-European initiative to combine all the deployment sites in Europe. All of them are obeying to the same standard, CITS, architecture, etc. With some difference that still need to harmonize, but it's a way forward, and it's why we have pilot deployment, is to ensure that we are able to have the same deployment, same thinking everywhere. So C-Road is very important project. We have one important project in front that is called Scoop, and indeed, where we provide you some information. You have even some link where you get more. There's not much public information from Scoop because it's managed by the Direction Générale des Routes, and they don't communicate so far very much. I don't know why, but that's so limited information. My company has 200 vehicles equipped with our communication solutions. So we have it's a patrol vehicle from the Deer West in Bretagne, and you also equipped police vehicles, buses, and one ambulance. So because that's typically the type of vehicle that we want to use CITS services first before we get to wide deployment everywhere. And there's also autonomous vehicle program that use these technologies. And INRIA, for instance, I've done a lot of work on that in my team where I was working at YoGoKo, but also other teams at INRIA. And just mentioning one of the latest projects from YoGoKo, Auto CITS. So it's the same technology, V2X, and the same standard were used for several use cases, not only traffic lights stuff, but other more interesting use cases like at toll roads, for instance, for the vehicle to notice that there's a toll road and to decelerate, etc. So there's also platooning, I think, was tested. Navia is using this technology for V2X communications at where they need to secure traffic lights, and they use all technology, by the way. So it's V2X by YoGoKo. And there is security initiatives involving people around here on the deployment of this certificate management system that I told you about, that is used by Deer West today. It's developed by those community of people, which is investigating new misbehavior detection. So when there is a misbehaving vehicles for that is intentional or not, could be it could be intentional in some situation. In some situation, it could be due to some defect. So this project is addressing such kind of risk, and there's a new project that is from TAM that is further working on that for automated use case, automated mobility use case. More initiatives on those projects, on projects that are not labeled as CITS project, but do integrate the CITS architecture and the functionalities in order to do more things like securing all access to the vehicle information, like in a SIGRAS project. SAS project is for welfare information. That actually the welfare information could also be used for safety. So this is where there is a combination of things together. And 5GAS, also Secure, is a project where they want to include V2X in the Euro NCAP rating for safety of vehicle. So it is very important because when it's achieved, it will drive the interest of the OEMs to implement V2X. And 5GAS is a project that is going to provide facilities for people wanting to test 5G technologies, and we are part of this project to provide the link between CITS and 5G. It's a real, there's a lot of interesting topic related to research on on the MEC, etc. It's not obvious how much it will work at the end, and there's a lot of challenge to use 5G for CITS services. Even though some stakeholders think it could be deployed right now, it's not the case. It depends what we think, what we speak about. For time critical applications, that needs to be insurance that the thing works on 5G. There's a lot of work to be done. So you have more links here for information about those channels. And sorry if it took longer, but I expected that my talk would be 45 minutes. So
It's 53 and a half.
I tried to rush without avoiding any topic. So.